In this video, we're going to demonstrate the Logix5000 software used to program the Control Logix and Compact Logix line of Allen Bradley PLCs. Right here, we have our Control Logix processor and rack. It's a 17-slot rack, slot 0 and then 16 slots for the I/O. Has a Logix5000 processor in there, and we've got an array of different I/O cards. Today we're going to be building a very, very simple demonstration program, primarily to show you how you configure the rack for the I/O cards and basically just get ready to start doing ladder logic programming. Let's come back here. I've got the software opened up, and I will be contrasting this against the older versions of Allen Bradley software, the Logix5000 and also the MicroLogix software packages. Like those, it uses RS links to establish communications between the PLC and the computer you're using to do the programming. So right here, you can see I've got a serial link set up, a DF1 link, and we have our processor right there, and I had a program in there called Tony00 Hello World. I'm going to overwrite that program, create a brand new one. I just wanted to show you that RS links is set up and running, and that will have to be done before you do any programming in your PLC. So here we go. I'm going to create a new project. So I get to choose which type of controller it is. We already are set up here for a 5550 controller, Rev 13. Chassis type, 17-slot chassis. We also have options here. We happen to have a 17 slot, so that's what we do. And slot 0, I get to choose which slot the processor goes into. It's kind of a new feature. With the older Logix5000 PLCs, processor had to be in slot 0. Here I could put the processor in any slot that I want, but just out of tradition, I'm going to keep it in slot 0. And then I choose the directory under which I want to create the project, and of course I got to give it a name. In true programming convention, I'm going to call my first program Hello World. That's usually what a programmer calls their very first program, just a simple demonstration program to show how to get the thing up and running. It's not going to do anything practical. There we go. Click OK. It's busy thinking about what it wants to do, and it's going to bring up a window over here, a pane, where you get to see the various aspects of the controller, including the program, main routine right here, and currently there is no program. There's nothing here for us to look at or to edit. We have to do some more configuration first. What I'm going to do here is go into I/O configuration. We need to tell it what cards are in the rack. So a brand new module. We're going to pan the camera up here. Take a look at our first module, which happens to be an AC output right here. I can swing this door open. This is a model 1756-OA16. It's an AC triac type output module, and it is in slot 0, 1, 2. So slot 2 right here is where that module is going to go. So we come down here, and we select the 1756-OA16 out of this enormous list. Right there, click OK. Major revision 2, I know that happens to be correct for this I/O module. I have to give the module itself a name. This is going to be important for some applications. I'm going to call this AC output. I can even give the module a description if I wish. I'm not going to do that here. Revision level 2.1, that's okay. And then electronic keying. I can tell the software whether this module has to be an exact match for what's going on here, if it doesn't care at all, or if it just has to be compatible. I'm going to stick with the default of compatible. And of course I have to choose a slot number. In this case it is slot number 2. As we counted before, it was in slot 2, a couple spaces over from the processor in slot 0. I go to next, and I can choose a couple options here, whether or not to inhibit the module, and whether or not to go on switch the controller to a major fault if there's a connection that's failing while it's in run mode. And then I've got a few module properties. I go to next. Now this is a really, really cool feature, very different from what we saw on the Logix5000. Here I get to choose what the outputs will do in various states of the processor. Now of course when the processor is running, the outputs will do whatever the user program tells it to do. But here we have some interesting options. When the processor is in program mode, I can tell these points what to do, and the default condition is off. So I could, for example, tell it to hold its last state, or I could tell it to default to the on mode or the off mode when the processor switches to program. That's a really cool feature because in older generations of the PLC, the output simply turned off when the processor went to program mode. Here I've got some other options. Ditto with fault mode. if the processor detects a fault condition. In other words, it's running, but it's faulted. There's some problem that has been detected. I can likewise tell these outputs what to do. By default, the option is to turn off. However, if I want to, I can tell them to hold their last state or to go on. This could be important, I should say it is important for safety. If your machine is being controlled or your process is being controlled by a PLC, you want to be able to specify what those I/O channels will do in the event of a program mode switch or a fault detected. Next I go here, and let's see, a couple of other pieces of information, then I say finish, and there we go. Now I have a brand new card in slot 2, a new module in slot 2, AC output. Well, I need an input card here for my Hello World program, so new module, pan back up here. My AC input card happens to be in slot 9. It's a 1756-IA16. It's an AC input card, 16 channels. Come down here and select from this vast list IA16 right there. Major revision 2, which I know is correct. We have to give this a name as well. I could give it a name according to some feature of my process, like maybe push button switches or limit switches or whatever that would be descriptive of the devices hooked up to it. In this case, I'm just going to call it AC input. Likewise, I could put in a full description if I wanted to as well. Revision 2.1, that's fine. Compatibility mode, cool. Slot number, I need slot number 9. That's the slot that we saw was in. Next, I can inhibit. I can tell it to create a major fault if the connection fails. And then here I've got options to enable change of state, able to detect off to on or on to off. I can select that. By default, these are all checked. Normally I want this to be able to detect all transitions of the input. And then I can also select filter times, off to on to off. I can select variable amounts of filter time that the card uses to filter the signals. And finish. So I'm done with that. So I've got two modules in slot 2 and slot 9 respectively, AC output, AC input. Now I go to main routine, double click on that, and here is my palette for programming a ladder logic user program. So I'm going to start editing this. I'm going to drag over a contact instruction, and I'm going to right click right here and say new tag. Now one of the major differences between the Logix5000 programming software and the old versions, everything is tag name based. Gone are the days where we address inputs and outputs by I:whatever. Here we actually create tag names, which becomes a very useful and powerful way to define variables in the program. New tag. I have to give this tag a name. Now this is going to come from a real life discrete input, so I'll call this push button switch, so maybe start switch. I can also give it a full description, a paragraph description if I wish. This connects to a real-world push-button switch with NO contacts. There we go. Then I get to select the tag type. The base type refers to an internal variable in the PLC's memory. An alias, which is what I'm going to choose here, refers to an alias for real I/O. So here, if I pull down the alias, it shows me here's all the different things that this name, start switch, could be an alias for. The closest analog to this in the old world of SLC 500, we'd call this a symbol. We'd give a symbol to a particular input or output address. In this case, though, we call it a tag name, and we have a lot more flexibility with how we reference those tag names to various places of memory in the PLC. So remember, this is for a start switch. This is an input, and our input card was on slot 9. When we go down here to our tag names, it shows the physical addresses here of the various cards. We know that slot 9 is our input card, our analog input. We have a couple of different sets of variables, one with a C, one with an I. The I refers to input, and the C refers to configuration. So here I want the I can expand that. And I've got fault information and also data right here. I want the data. This is going to be the actual bits turned on and off by switches connected to the inputs. Notice I get a pull-down menu right there. That's where I get to select which bit on that card is going to refer to the tag name start switch. So let's say that which channel I should say. let's say that I select channel 5 or bit 5 in that word. So there we go. I click OK, and there is my examine if closed instruction right there that has a hardware referenced address local:9:I.data.5. Again, that means local chassis, slot 9, input, data, and bit number 5 of that 32-bit word. So, next step, I'm going to put a coil in here to complete my very simple Hello World program. The coil likewise has to have its own tag name, its own reference in memory. So right-click, new tag, and I'm going to call this, let's see, motor jog. And I could give this a description, a whole paragraph description if I wanted to. This output channel connects to a contactor coil to drive a motor. And I'm going to choose it as an alias again. It's not going to be an internal bit in memory. It's going to be an alias for a real-life I/O point. Remember, this goes to the output card, which, if you recall, is in slot number 2. So notice I've got a few different listings here for local 2. Here is configuration, input, and output. Now, configuration, of course, holds data relevant to that card's configuration. This is an output card, but it still has a set of input variables. This is basically monitoring the fuse states for that analog or that discrete output card. I want the actual output bit, so I'm going to choose this one right here, local chassis, slot 2, output bits. Got data right here. Notice the pull-down menu that appears. I get to select the bit of this card, the particular channel on the output card that's going to be driven by that coil instruction. I'll select bit number 8 just for fun, and I'll click OK. So there we go. There's my simple program. I can do a syntax check, and it clears the check OK. So we're looking at a examine if closed instruction with the hardware address reference right there, my tag name, and the description. And then over here, a coil instruction, output enable coil, with hardware address reference, my tag name, and another description. Of course, at this point, I need to download this program to the controller. So here we go. Download. Failed to go online. Okay, it needs to know the communications path. So go to communications, who's active. It references the data in RS links. I want the serial link right here. I want that controller, and I'm going to say download. And we wait. Almost done. Change controller back to remote run? Sure. So I'm back in remote run. You can see the green power right here, so it's ready to go. This is a running operating program. My very simple Hello World program is actually running. At this point in time, I do not have a real world switch hooked up to channel 5 of that card in slot 9. So to make this program run, I'm going to have to force the bit. And I can do that just like I could in the Logix5000 software. I can right click and say force on. I can force that input bit to the on state. Then I come up here to forces, and I will enable all the I/O forces. Enable forces, yes. And notice when I do that, that colors as well, meaning that bit is being forced and sending data to that coil instruction. So if I come over here to slot number 2, we can see right there the little number 8. It's hard to see, but that 8 is lit. If we keep the camera focused on that, I will remove the forces. And we should see that turn off. And yeah, the output's channel 8's no longer on. So we remove the forces and that channel turned off. So back to this. We have ourselves a running program, and hopefully a better understanding of what you'd have to go through to configure this and get it to work. Remember, we had to tell the software what sort of controller we were dealing with, which slot the processor was in. We had to configure modules, what types of modules, what slots they're in, and the various states that would be allowed during program mode or fault mode. Then when we came up here and started writing our program itself, the user program, we'd come up here and right-click on the instruction, then create a tag name, and then reference that tag name to the real-world I/O. So there's some interesting differences between this and the older generation Logix5000 software or Micrologix software. Very powerful stuff here, lots of features. We have just barely scratched the surface of this software, but I wanted to shoot this introductory video to give you a taste of what life is like in the brave new world of the Logix5000.